Hello guys and welcome to another Arduino tutorial. Today we are going to be fading an LED using pulse width modulation, PMW. This is lesson 7 in the Ultimate Arduino Beginner's Guide series. It's quite complicated today, so you need to be paying full attention to the video to understand it. Right, let's move on. You will need today a Arduino or clone, solderless breadboard, jumper wires and an LED of any colour. Now, I've talked about in the past the LED, anode and cathode. The longer leg is the cathode, which is positive, which you need to connect to 5 volts. The shorter leg is the long leg is the anode, which you connect to 5 volts, and the shorter leg is the cathode, which you connect to ground. Long leg, anode, positive, short leg, cathode, negative. We've done that in lesson 2. So, first we need to talk about what is pulse width modulation. Pulse width modulation, or PMW, is a technique for getting analogue results with digital means. Digital control is used to create a square wave or signal switched between on and off. The on-off pattern can simulate voltages in between full on 5 volts and off 0 volts by changing the portion of the time the signal spends on versus the time that the signal spends off. The duration of on time is called the pulse width. To get that varying analogue values, you need to change or modulate that pulse width. If you repeat this on-off pattern fast enough, with an LED for example, the result is if the signal is getting a steady voltage between 0 and 5 volts, controlling the brightness of the LED. Right, here is a diagram of pulse width modulation where we've got 0% duty cycle, which would be analogue right 0, 25% duty cycle, which is analogue right 64, 50% duty cycle, which is analogue right 127, 75% duty cycle, which would be analogue right 191, and 100% duty cycle, which is analogue right 255. So, in the graphic to the side, the green lines represent a regular time period. The duration, or period, is the inverse of the pulse width modulation frequency. In other words, with Arduino's pulse width modulation frequency is about 500 Hz. The green lines would measure about 2 milliseconds each. A call to analogue right is on a scale of 0 to 255, such that analogue right 255 requests a 100% duty cycle always on, and analogue right 127 is a 50% duty cycle on half the time, for example. So you should kind of understand what pulse width modulation is now. Right, now you need to wire up your components. A very basic wiring diagram. So just wire all that up now. I'm going to give you a couple of seconds to pause it so you can get it wired up. This is shockingly bad. Okay. The code. The code today is quite a lot more hard than what we've done in the past, so pay full attention please. Right. Int LED equals 9. Integer variables, we've done them so many times now. We've just said that the LED is so the pin 9 is the pin the LED is attached to. If we go back here, pin 9 is the pin that the LED is attached to. Okay. Int brightness equals 0. How bright the LED is. It needs to start off at 0. We've created a variable there, which is basically saying what the brightness starts off as. And then int fade amount equals 5. How many points to fade the LED by? This will all make sense to you in a second if you don't get it now. So void setup. And then we got 2 brackets facing each other, an opening curly bracket and a closing curly bracket, as we've done 1,000 times. Pin mode, LED output. So we're setting the pin 9 as an output. Pin 9 is the one it's attached to. Pin 9 now can be controlled whether we send 5 volts out of pin 9 or not to the LED. So, let's have a look at the next bit of the code. If you're confused by this whole thing, don't worry, everyone is at first. But I'm just going to explain it all to you now so that you understand it. So, void loop runs forever, so this will just repeat over and over and over again. So it says here, set the brightness of pin 9. Analog right, LED brightness. So this is saying now if we analog light, LED is pin 9, brightness is 0. So it's basically turning the LED off. 0. Nothing in it. Now, change the brightness for the next time through the loop. Brightness equals brightness plus fade amount. Right, so brightness equals 0. But now we're saying brightness is brightness plus fade amount. Brightness plus fade amount is 0 plus 5. Okay, so now the brightness is 5. Okay, and then it's going to go back round and say it's 5. Reverse the direction of the fading at the ends of the fade. If brightness equals 0, brightness equals 225. Fade amount equals minus fade amount. That might be quite confusing to you. It's still quite confusing to me, to be honest, but that's just what you need to write to reverse the fading. And then wait for 30 milliseconds to see the dimming effect, delay 30. That's not 30 seconds, that's 30 milliseconds. And it goes back round and it repeats and it repeats and it fades in and fades out. And then that's the finished code. Now, I've set you 2 challenges to complete for this code. Just copy that into your Arduino IDE. I'll give you 5 seconds to do so. To just pause it so you can copy it in. Okay. 2 challenges. Modify the code so it fades faster. And challenge 2. Can you write a piece of code which has 2 LEDs fading, both at different rates? These challenges are quite challenging, but that's the whole point of them. If I set more challenging challenges, then it's going to be harder for you to figure it out, and it's going to really push you, and then you'll have a greater understanding of it. And that's all for today. Thanks for watching, and be sure to watch my many other Arduino tutorials. If you were stuck with anything today, please email our unofficialarduinotutorials@gmail.com, or just post a comment in the comment box below. Thanks for watching, and I will see you next time. Goodbye. Stop. Goodbye.